You know, we've all seen the pictures, we've heard the stories, but what if we actually took it all seriously? Not as proof, but as a kind of scientific puzzle. Well, a recent paper by Dr. Robert C. Davila does exactly that. And with his background in things like cosmology and evolution, he turns this whole wild idea into a fascinating cosmic detective story.
So here's the basic idea. Let's just assume, for the sake of argument, that these descriptions of the classic gray alien are totally accurate. The point isn't to prove they exist, but to use their biology as a set of clues. It's like we're reverse engineering their homeworld. Think of it like a cosmic CSI investigation.
All right, so where do we even begin a case like this? You start with the body. The paper makes a great point. An organism's body is basically a roadmap, a story written by millions of years of evolution. Every single trait tells you something about the world it came from.
And our first, most obvious clue? You gotta start with those giant black eyes. Here on Earth, features like that don't just pop up for no reason. So the question is, what kind of world would push evolution to create eyes like these?
Well, the answer is pretty clear. A world that's really, really dim. Huge eyes are basically light-collecting buckets, perfect for catching every last little photon in a low-light environment. So that points us to two big possibilities. One, their planet orbits a faint star like a red dwarf, which, by the way, are the most common type of star out there. Or two, they evolved deep underground in huge caverns, far away from the light of any sun.
Okay, on to the next clue, the body itself. You compare it to a human who's built to handle Earth's gravity, and this being is described as, well, slender, frail, almost fragile. And that makes you ask a really important question. What's the one force that shapes our size and strength more than anything else? It's gravity.
And that leads us to our second big deduction. A body that doesn't need big muscles or a heavy-duty skeleton is almost certainly a body that grew up on a planet with a lot less gravity than Earth. So now we have our two main search criteria. It's got to be a low-light world, and it's got to be a low-gravity world.
So with our biological profile figured out, we can switch gears from anatomy to astrophysics. Now we have to ask the really big question. How many potential homes are even out there? I mean, is it even plausible to think another intelligent, space-traveling civilization could exist?
To try and get a handle on that, scientists use this famous tool called the Drake equation. Now, it's not some magic formula that spits out a perfect answer. It's more like a way to organize our thinking. It makes us consider all the different variables. You know, like how many stars are there? How many have planets? How many of those could support life? And so on.
In fact, the guy who came up with it, Frank Drake, said it himself, this is all about getting a ballpark idea, not a precise number. And the paper we're looking at uses some really conservative numbers for all the variables, especially for the chances of life becoming intelligent and then building spaceships.
So, after you crunch all those cosmic probabilities, what do you get? Even with those cautious estimates, the number is 36. 36 active, intelligent, spacefaring civilizations that could exist in our Milky Way galaxy right now. That's our starting point.
But hold on, the Milky Way is just enormous. So even if there are 36 other civilizations out there, getting from their star to ours is a huge, huge deal. So to make our search actually practical, we have to draw a circle around Earth, a realistic travel bubble.
The paper lays out some pretty logical rules for this. Let's say a species has a lifespan kind of like ours, and they can travel at a mind-bogglingly fast, but still theoretically possible, 20% of the speed of light. That gives us a search bubble with a radius of 50 light-years. That's our cosmic neighborhood.
Okay, let the great cosmic filter begin. So, inside that 50 light-year bubble, how many star systems do we have to work with? The number is roughly 1,400. That's our initial pool of suspects.
Now, let's apply our first clue from the anatomy. We need a low-light world, right? So that means we're mostly interested in those dim red dwarf stars. Once we apply that filter, our list of 1,400 systems drops down to about 1,000.
But just having the right star isn't enough. You need the right planet. So out of those 1,000 red dwarf systems, how many have confirmed rocky planets in what we call the habitable zone, where water could be liquid? Well, this is where the number just plummets, down to 8. Just 8 systems. We've gone from 1,400 potential suspects to a final list of 8.
Okay, so this is it, the final stage of our investigation. We have our short list of candidates, and now it's time to see which of them really fits the complete profile of our theoretical visitor.
And here they are, our top 8. 8 star systems all within our 50 light-year bubble. all with potentially habitable worlds. You can see our closest neighbor, Proxima Centauri, is just 4.2 light-years away. The farthest on the list, TRAPPIST-1, is almost 40 light-years away. Now we just need our final clue to really zero in.
And that brings us right back to our second biological clue. Remember, we aren't just looking for a dim world. We need a low-gravity world, the kind of place that would produce that small, frail body type. This is the very last filter we're going to apply.
So, when we check the known data for the planets in those 8 systems, looking at their mass and their size to figure out their gravity, 2 candidates just jump off the page. The planets in the TRAPPIST-1 system and the planet orbiting our closest neighbor, Proxima Centauri, are the best matches for both low light and low gravity.
And just look at the numbers. On Earth, gravity is 1.0 g. But on a planet like TRAPPIST-1F, the surface gravity is estimated to be just 61% of that. Proxima Centauri b is at 87%. Any creature evolving there would have a totally different relationship with gravity, which fits that slender build perfectly.
So after following this long trail of clues, all the way from biology to astrophysics, this incredible thought experiment gives us 2 prime suspects. The highest probability points to either the TRAPPIST-1 system, which is packed with low-gravity planets, or Proxima Centauri, literally our next-door neighbor in the cosmos.
Now, of course, this was all a what-if exercise, a fun, deductive game based on a hypothetical. But it does lead to a pretty powerful final question, doesn't it? We started with what seems like science fiction, and we ended up right here, in our own cosmic backyard. And if the potential for intelligent life really is that close, what does that actually mean for us?